Okay, so hello everyone. Today we will be solving LeetCode's POTD, which is closest prime number in range. Okay, so the question number is 2523, and as we can see, it's marked as medium. Okay, so now let's try to see what the problem is all about and try to solve it. Okay, so let me just zoom it a bit. Yeah, so given two positive integers left and right. Okay, find two integers num1 and num2 such that left is less than equal to num1, which is less than num2, and which is less than equal to right. Okay, so both num1 and num2 are prime numbers. Okay, so and n2 minus m1 is the minimum amongst all other pairs satisfying the above condition. Okay, so yeah, just return the positive integer array answer where n1 num1 will be here and num2 will be here. If there are multiple pairs satisfying these condition, return the one with the smallest num1 value. No such if no such number exists, return -1 comma -1. Okay, so let me just explain the problem. Okay, so we have been given a left and a right integer value, and we need to find all the prime numbers in the range. Here, as you can see, here are all the prime numbers in the range, and we need to return the pair which has the smallest distance, like which has the smallest difference between them. Okay, so right, like in this case 11 comma 3 has a difference 2, and 17 comma 19 has also a difference of 2. So in this case, as you can see, like here it is written, if there are multiple pairs satisfying these conditions, return the one with the smallest number value. Okay, so number value here is 11 and here it is 17. Like you can see, the format is like this. Okay, so 11 is less than 17, so 11 comma 13 will be our answer. Okay, so this is the problem, and I think the problem is straightforward. There are no loopholes and such kind of things in it. Okay, so we just need to find the prime numbers in this range. Okay, so we do know how to find prime numbers. Okay, so uh, we all know, like, first what the prime numbers are. It is the numbers which are divisible by 1 and itself. Okay, so those are the ones which we call prime numbers. Okay, and plus 0 and 1, these aren't prime. Okay, 0 and 1 are not prime. Prime numbers starts from 2. Okay, so we need to find prime numbers in this range. So yeah, we can find out, but like if we go in the traditional way of finding the prime number, the time complexity will be like it it will not suit for this case, because as a constraint you can see it's right, it's a big constraint, so that solution won't work. Okay, so there is a very famous trick or an algorithm which we can say, which help us to find the numbers in a range, prime numbers in a range. Okay, so um, some of you might be aware of it. It's the sieve of Eratosthenes, right? It enables us to, like, it helps us to find the prime numbers in a range. Okay, so let me just read it for you. Sieve of Eratosthenes is an algorithm for finding all the prime numbers in a segment from 1 to n. Okay, using the using big O of n log n's operations. Okay, so as you can see, here's the time complexity. The algorithm is very simple. At the beginning, we write down all the numbers between 2 and n. Okay, we mark all proper multiples of 2 since, okay, so this is the trident. Okay, we mark all like, let me just, yeah. Okay, so as you can see, here are the operations going on. Like we are running it for till 16. Okay, then the prime numbers from 1 to 16. Okay, so as I have told you before, 0 and 1 are not prime, so we won't be considering them. Okay, so we mark all proper multiples of 2 since 2 is the smallest prime number, right? Because 0 and 1 aren't prime, so 2 is the smallest one. Okay, as suppose a proper multiple of a number x is a number greater than x and divisible by x. Okay, so we know what the proper multiple is. Then we find the next number that hasn't been marked and as composite. In this case, it is 3, which means 3 is a prime, and we mark all proper multiples of 3 as composite. Okay, so let me just told you. Let me just tell you. Okay, so we start from 2. Okay, so and we move forward. Is 3 divided by, is 3 a multiple of 2? No. Is 4? Yes. Mark it down. Okay, so we won't be considering this in future. Is 6 a multiple of 2? Yes, so mark it down. We won't be considering this also. Is 8? Yes, so mark it down. We won't be considering it in the future. Similarly, for 10, 12, 14, and 16, we won't be considering this in further cases. Okay, as you can see, it is marked down, right? So, yeah, this one and this one. Okay, so which is the next number? We have 10, 2. Now we start from 3. Okay, 4 is already marked. 5, no, it isn't divided. It is not divided by 3. 6 we have already marked out. 7, no. 8, no. 9, yes. So we cancel out 9 also. Okay, we won't be considering this also. 12 already marked by 2. For 13, no. 14, no. 15, yes, we need to mark it. Okay, so these are, see the numbers which are colored, we won't be considering them, like 4, 6, 8, 9, 8, 9, 10, 12, here 14, 15, 16, because they were already marked by someone. Okay, so now let's see now which number is remaining. Like 5 isn't marked out, so let's do it for the 5. No, 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 like here till no. In this also, like if we're going for the 5 multiples, 15 is already marked out, so 5 will be just okay. Similarly for 7, the, like you can see, 14 would have been marked out by 7, but it's already marked out, and none of the elements are getting divisible by 7. So okay, so for 11 also, you can see no element is marked out by 11 also, and similarly for the 13, but we will be like going for it. Okay, so we will go for 7, we see, we go for 11, we see, we go for 13, we see. Okay, so at last what is remaining with us? The elements which are not cut out are the elements which are prime. Okay, so this is the concept of sieve of Eratosthenes. Okay, so what will it help us with? It help us with the to find the numbers in the range which are all prime. So what we can do? We can just, like here you can see left and right. We can just find out all the numbers in the range. Am I right or wrong? Right? I'm right. Okay. So yeah, as you can see, here we find out all the elements which are in the range. Right? So what we just need to do, we just need to find out the pairs whose difference is minimum, right? So we first find it for 13, 11, right? This is a pair, this is also a pair, and this is also a pair. So as you can see, there's a difference of 2 here and 2 here. Okay, since this pair is smaller than this one, this is smaller than this one, so this will be our answer, right? Okay, so like just see another example. Here left is 4 and right is 6. Okay, So only 5 is between them, right? 5 is the only prime number which is between 4 and 6. So 5 doesn't form a pair. So what will be our answer? It will be minus 1 comma minus 1. Okay. So let me just go through the code also. So things will be more clearer to you. Okay. So okay. So we have declared what global vector which is prime, and we have created a function Sieve. Okay, Sieve will set the prime numbers between the range. Okay, so as you can see, this is the code of Sieve of Eratosthenes. You can also check it out on YouTube, and also you can learn more about it. Okay, so what are we doing here in the main function? We are setting Sieve for the like the what will be the right will be the greater value. Okay, so we are setting the higher bound, we can say. Okay, so as soon as we are storing the prime numbers from left till right in an array. Okay, just for the simplicity we are doing it, right? So we will be having all the prime numbers in array, in the range of left to right. Like this will be in an array. So we just need to find out the difference between the elements. Okay. So like this is for the, you might get stuck because for the like, if the size is answer size, sorry, if the array size is less than 2, we can just simply return the answer. Okay. Because there might be one element or zero elements in it. Okay, so if it's greater than 2, then also, then only we can find a pair, na? So that's why we are checking. If it's less than 2, if it's less than 2, we are simply returning our answer, which will be initially having value minus 1 comma minus 1. And we are like in the, before finding our answer, we are setting difference to 1E9. 1E9 is a bigger value. Okay, so like what do we say? Like, okay, so yeah, it's a bigger value. Or we can also take the interpacks, like, right? So for checking the pair, we are going till less than ar dot size minus 1. Okay, so yeah, just a second. Yeah, so here we are finding if the current difference, like between the pairs, if it's less than the difference, then we are updating it. Okay, and we are updating also the difference. Okay, so it will ensure that, see, we need to prioritize the difference, but if the difference comes same, like here in this case, we need to take the smaller value. Okay, so this will handle that. Okay, this will handle it, and simply at the end we can just return our answer. Okay, so that's all for this question. It's a good one, I would say. Yeah, the question is clear. If you know this concept Sieve of Eratosthenes, it will be very easy for you, I guess. Okay, so yeah, that's all for the question. I will give the link of this Sieve of Eratosthenes plus the question link, and the code link will be in the description box. Okay, so yeah, thank you everyone. That's all for this question, and have a good day ahead.